explain through PPT, that is not very effective. And instead of going to advanced technology, because all of you are teachers, and I have been, besides being a scientist in TIFR, Samir, which is in IIT Bombay campus, I used to teach on regular basis for the MTech course in IIT Bombay Electrical Engineering Department. So there as well as in various places, Goa Engineering College. Then when MTech course started in Mumbai University for the first time, there was no one to teach RF and microwave in Mumbai University. So literally Saturday, Sunday I used to go and then teach 6 hours on Saturday, 6 hours on Sunday, and then that is how the course used to get completed, particularly RF and microwave this thing. So what I feel that whatever is there in literature that you can read, and you can understand, discuss among your colleague, and then you will grasp the concept. But if some old professor like me who has taught over the years and then gathered some important points which he wants to share with all the teacher who will be teaching, you as a teacher are social builder, Many times we get a comment from international community that engineers in India are half cooked. They are not up to the international level. So very concerted effort has to be made for the upgradation of knowledge of all the teacher. So this type of course really make you interact with what is going on, and then also interact with some of the senior people so that they share their views, and that is how you pass on whatever these things are there to students. All of you are teachers, all of you are capable individuals, but then I thought some points about my field, which is primarily electromagnetics, and that too very subsection of the electromagnetic is RF and microwave. So those things I thought I will share some of the finer points in 1 hour. So, but then I will be using the board so that you can interact me wherever you have doubt. So that we will do in next 1 hour. Then after that, lab visit will be there, and then Dr. Rajesh will take over. So we will start with the basics. I will touch upon following things. We will start with very, very basic. Whenever there is some conference here in DIIT, I encourage you all to come here and then listen. 3 days back, 4 days back, the Professor Paul Raj, kindly listen to this name. Professor Paul Raj was here. He is an engineer from NDA. Then he did his PhD in record 2 years from IIT Delhi. Though he was a naval officer, Commodore, he established the lab you must have heard, that is CARE, DRDO lab in Bangalore, NPOL, and one more lab he established. Then after serving for 20 years for Indian Navy and DRDO, he was invited as a professor in Stanford University. He was full professor till recently. Now he is serving as professor emeritus. So while introducing him, I said that he learned everything in India. He did not go abroad to get MS and PhD degree. He learned everything here and then went out to teach the whole world. He is a renowned professor. His research work is responsible for 5G and 6G communication. He is the pioneering person who has done pioneering work on MIMO, you must have heard, multiple input, multiple output, that system. And he has 86 patents in MIMO itself. But he initiated a topic, and I was reading his biodata. 57,000 PhD has come after he introduced MIMO. There are 37,000 patents that has been filed in MIMO internationally after he introduced the course. So, I mean, try to be little bit more what you call forthcoming, and then you all as a teacher should attend this course. वहाँ खुल जाता है, समझ रहे हैं ना? ये तो हम we stay in engineering college and then we वो कुआं का मेंढक के जैसा बन के रह जाते हैं. You should come out. Come here, like it is a very good initiative. Now, this is not comes under Secretive Institute. This one is now opened up for industry, for all engineering college, and then we don't get time. So at least 10-20 invitation comes every year to become their that board member, management member in various engineering college. So yeah, this is a place where now being encouraged so that to open up, and then you also utilize that. Come here, see what are the facilities. Ask for time. There is also PRO of the institutes. Like this is a unique institute, only institute which comes under academic institute comes under Ministry of Defence. Like you have DAE, SBNI is there in Bombay. You have IIST, that is for ISRO in Trivandrum. So this is a unique these things, and that happens to be in Pune, and most of you might be around belong to around Pune. So kindly utilize these things. Maybe we will have busy schedule, may not respond for 3-4 times, but if pursue, then naturally during free time we will accommodate your request. So utilize this government facility. It is meant to what do you call? It is meant for all the local teachers, local scholars, and local researchers. So with this one now we will start. We will start with the basic concept of signal. I would like to emphasize some few points that how there are lots of myth we call microwave frequency. You must have heard. There is nothing called microwave frequency. It is not technically correct word, microwave frequency. Why it is so, we will see. We will also see why you need to have the knowledge of RF and microwave. Only sitting in one corner, if you want to excel in your life, in your field, you also should be multidisciplinary. And earlier, electrical engineering never used to require the knowledge of microwave. Computer engineers never used to require the knowledge of microwave. The robotics people, aeronautics people, they never used to require the knowledge of microwave. But now it is must for all the discipline people to know about microwave. Why? Why I'm emphasizing this one? Because let us say you are a semiconductor physicist, or you are semiconductor engineering, and you design a chip. Now chip size will be very, very small, and in that one all the subsystems will be there in that chip. So you will have antenna to radiate, you will also have a transmitter there, receiver there, wireless system. When you are designing a receiver or transmitter or antenna, there will be interconnect in the chip which will connect the output to the antenna, transmitter to antenna. So the person who was designing a chip is not a microwave engineer, but then the impedance transformation concept has to come in. Otherwise, when you are making a transmitter and connecting that to antenna, and you don't take care of the impedance matching, this everything will get reflected back, nothing will get radiated. That is one thing. So that is microwave knowledge is required for that one. Then we are talking about 5G, 6G. Computer people are also transferring the data through clouds, through wireless medium. So when earlier when the clock speed was in kilobyte per second, kilohertz frequency, that is low frequency. But now, because the large data rate for which large bandwidth is required, you are shifting the frequency and your clock speed is now in Gbps. And when you talk about Gbps frequency, you need to know the gigahertz technology. Then only you will be able to understand that one. So computer engineer who is working on AI or data management, data science, all those people also need to know the basic concept of RF and microwave, So that's why I will try to cover a little bit about RF and microwave basic. Then we will come, if time permits, we will see that what is the basic difference. In school, when you are introduced in 9th standard, the basic concept of this voltage and current and Ohm's law, Thevenin's theorem, Kirchhoff's law, all those things comes. How we define that Ohm's law? That 2 volt battery, you connect that to 1 ohm resistance and connect the circuit. Current which will flow is 2 volt divided by 1 ohm resistance, so it will be 2 ampere. We only talked about magnitude of the voltage and current, right? But then that will not hold good at high frequency. When the wavelength becomes comparable in microwave frequency, wavelength, you will see wavelength will be in centimeter. So in that frequency, component size is comparable to wavelength. So when you are inputting the signal, output will go that much phase change. So if you are designing a power combiner and you have not taken care of the lead length and transmission line length, and if it is around half wavelength correspond to 180-degree phase difference. So instead of combining, they will cancel each other. Instead of getting 2 signal added, you will get 0 signal. So in low frequency, we deal only with magnitude of the signal, voltage, current. We only deal with magnitude, and that holds good. All these calculations what we have done, that holds good. Maximum power transfer theorem, couplet conjugate will happen and maximum power will get transferred. There also we only talk in terms of amplitude. But in high frequency, because of the transit time, you won't be able to neglect. Insertion phase of the device, you will not be able to neglect. There you have to take phase correction. So signal will have amplitude as well as phase. That is the difference. In low frequency, most of you might be teaching Z matrix, admittance matrix. Transistor is represented by H matrix, HOE, HIE, HRE, all those things. Those things doesn't hold good in microwave frequency. All these things are summarized, and consolidated, and you talk in terms of scattering matrix. Because here, when you connect a voltage, that current will flow, and we don't talk about forward moving current, reverse moving current. Whereas in high frequency, when phase is a inbuilt ingredient of the signal, you need to know amplitude as well as phase. So then concept of what do you call that vector space comes into picture, amplitude and phase. So that is how then this Ohm's law, Thevenin's theorem, Kirchhoff's law, maximum power transfer theorem gets translated to Maxwell's equation. Where you have amplitude and phase. When the voltage is moving, we say this is the voltage between 2 points, and then we connect that one. We only say that current will flow in forward direction. But actually, when you go to the wave concept, it will go in this direction. If there is impedance mismatch, then current will return back. So there will be forward moving wave, there will be reverse moving wave. And those things, please come in. So those things are in generalized. You can get accommodated here once it is there. Kindly.
चेअर नाही ते खाली घ्यायचं.
Yeah. So all these things let us see quickly, and then next time when you teach RF and microwave, you don't call that wave microwave. You know, we will see that. So I just emphasize. Many people I find are highly disinterested in the beginning itself. Class should resonate, you know. Then only maximum power transfer will happen, you know. And so I have seen 7 of you who are not interested and are not listening in the class. Unless you give, whatever this old man is telling, if you try to follow a little bit, that will be the biggest reward for me. You know, those type of felicitation and all are not required. Whatever I have gathered over the years, if I am able to pass on to teachers who will be teaching and preparing a good engineer, then the purpose is solved. So kindly, physically you people are there, you try to be mentally present in the class. Yes, madam.
Yes, sir.
Second batch, first two madams, you know, I remember that. I have been taught in Mia's psychological concept to recognize the students whether they are mentally present in the class or no. So I can make out. In my class, in IIT Bombay, there used to be 120, 125 students. I used to know them by name. So that then only you can transfer whatever little you have gained. Okay. There is less time. I will not lecture much. We will just see the signal. How do you define signal? You write A sine A is the amplitude, sine omega t plus phi. That is how we represent signal. What is A? It is amplitude. And then sine omega t, so time function is there, also frequency function is there, and then also phase is there, isn't it? So in low frequency we only deal with amplitude, you know, but in high frequency all other these things also becomes equally important. Now how do you define frequency? When rotation per second, that is how we define frequency. And then the ninth standard one, that French sister had taught me that she drew like this, you know, and this is crest and trough, right? So if this happens, you know, one full cycle, then another one half cycle, another half cycle. What she did, I still remember. You know, she cut this one and put here, the door this one. So you can see it is coming back to same point, and if that happens in 1 second, that is 1 hertz. If it happens many times, then so many hertz will be there. This is what it says. This concept also gives you the concept of path length versus phase. This one is half wavelength lambda by 2. This one is another half wavelength lambda by 2. So these together you are getting a circle. So one wavelength is 360 degree. This is the concept which you all have studied in 9th standard. That is one thing. Before going to microwave concept and all, you always remember the experiments you have done at 10th standard using tuning fork. You know, all the design equations of various components, antennas, that you can do automatically if you understand the basic concept of that experiment of tuning fork. What is done in that one? You have that wooden powder you spread, hit the tuning fork and put above the this wooden this thing. Then you will see there will be somewhere lots of powder will get accumulated. Then you will have rarefied. Then again these things. So wherever these things are there, where more these powders are there, those are nodes. and between two nodes there are empty nodes. So that is resonance. How you designed. What is the length between two nodes? Lambda by 2. What is the length between two empty nodes? Lambda by 2. And in one cycle there will be two nodes, two empty nodes. So that is how do you design dipole antenna? Dipole antenna. In dipole antenna, this is open circuit, this is open circuit. So if you consider open circuit as node, anti-node, then in between short circuit will be there. So this one will be dipole, two pole. So that is how this one will be lambda by 2. It is directly related with the tuning fork experiments you have done. Monopole means single pole. So there will be open circuit, it has to be a short circuit node and anti-node. That length becomes lambda by 4. So all these things are derived from there. Resonance, if you understand your tuning fork experiments. So that is also related with frequency, this one, and 360-degree phase difference you keep in mind. Now let us see about various frequency band. And then we will come why RF and microwave frequency is very sought after frequency range. Now we are moving to millimeter wave, and later on we are going to terahertz, and then beyond that also now we are coming back to optical communication, optical band. Why? Because huge bandwidth is available. How that fractional bandwidth and all those things are calculated, we'll quickly see from that 9th standard concept. Now if you remember, the basic frequency definition, that 3, I will not go lower frequency, 3 to 30 megahertz is known as HF frequency band. Then 30 to 300 is known as VHF, very high frequency. 300 to 3000, that is 3 gigahertz, right? 3000 hertz, this thing, megahertz is 3 gigahertz, this is UHF. Then we have L band, S band, C band, X band, K band, KA band, sorry, KU band, here KU band, K band, K band, V band, W band. You know this frequency range. This one is 1 to 2 gigahertz. This one is 2 to 4 gigahertz. This one is 4 to 8 gigahertz. X band, which was known as defense band, that is 8 to 12, 12 to 18 gigahertz, then 18 to 27 gigahertz, then K band is 27 to almost. People go different people have given different frequency range. This is 40 gigahertz, then this is 40 to 75 is V band, and W band 75 to 110 gigahertz. Okay. These are the various frequency band which are available. Means in 1 second those many rotations will be there. Okay. Now here if you try to see all this frequency, when you I don't know how many of you have gone to Mud Island. I always give example. Bombay, if you have visited, there they used to have AM broadcast system, AM broadcast, and you will see on the that seashore, near to seashore, marshlands are there. They have stretched the wire up to 1 kilometer, half kilometer. Why this thing is there? Because they are broadcasting lower frequency. You have seen that dipole antenna lambda by 2, so lambda will be corresponding to that frequency. Monopole antenna is lambda by 4, so corresponding to that frequency. So at lower frequency, what is the frequency of AM band? Around 1 megahertz, 800 kilohertz or 900 kilohertz, so it comes around 1 megahertz. What is the wavelength at 1 megahertz? 1 megahertz? Maybe 300 meter. How much is that? Around 300 meters. 1 megahertz. No, 300 meters. So to have one full crest and then trough, it will take 300 meter. So if you are trying to realize the phase difference of 180 degree, you have to have a cable length of 300 meter. If you are taking air dielectric cable length, So that is how those antennas are very large antenna. So those, and then what is FM band? Around 100 megahertz is FM band. 100 megahertz. Radio Mirchi 92, something like that. So around 100 megahertz.
88 to 108.
Yeah, so center frequency will be around 100 megahertz. Easy to remember that. Wavelength will be how much? 3 meter. 3 meter. So here AM band is 300 meter, FM band is around 3 meter. They are known as meter wave. Meter wave. Why? Because wavelengths are in meter. They announce also meter. So those things are meter wave. Huh? Meter. Now, if you talk about 100 gigahertz, 100 gigahertz wavelength will be in millimeter or fraction of a millimeter. What are those waves known as? Millimeter wave. Millimeter wave. When wavelength is in meter, it is known as meter wave. When wavelength is in millimeter, it is known as millimeter wave. Find out the frequency. Here, what is a microwave? People say that gigahertz frequency range is generally referred to as microwave. Pojar book says that 1 gigahertz to maybe 100 gigahertz is microwave. So gigahertz range is known as microwave. Find out the wavelength in that one. It will be centimeter, centimeter. All of them will be in centimeter. When wavelength is in meter, broadcaster tells it is meter wave. When wavelength is in millimeter, we have thousands of books in millimeter wave. Why millimeter wave? Because wavelength is in millimeter. So that is why I always tell this frequency is people call microwave. That there is nothing micro about microwave. It is actually centimeter wave. Microwave frequency range should be known as centimeter wave because that is how it is characterized. There is no microwave. But then why people call it microwave? Yeah, she's right. When Marconi did experiments, they were in 100 of kilohertz or something like that. And then from UK to Canada, wireless communication he proved. So what was the antenna used? Hughes tower monopole antenna with gay wire that was used. The size at lower frequency used to be gigantic, very big. And then when people started using microwave through spark gap and all those things, they started generating microwave. Then the size of the component was miniaturized, like she said. And micro word is attached with miniaturization. So that's why they called it microwave. But technical name should be centimeter wave. So that you always remember. Some of the Russian books, don't call it microwave. They call it centimeter wave. So that you keep in mind. So that is one thing you should remember.
Sir, wavelength is also 10 is for minus 60. More microwave.
कहाँ से -6 आ
Gigahertz wavelength.
मैडम सारा रामायण खत्म हो गया अब बोलती है सीता रावण की बेटी What is this? This velocity of light divided by frequency each wavelength, isn't it? So this is 3 to 10 to the power 8 meter per second, and let us say microwave if you take 1 into 10 to the power 9 hertz. So this will become 0.3 meter, so 3 centimeter. कहाँ से 10 to the power -6 आपने कर दिया? थोड़ा सा ध्यान दीजिएगा, नहीं तो एक बार फर्स्ट क्लास में आप स्टूडेंट का वो हो जाता है तो देन थ्रू आउट द सेमेस्टर दे विल बी बूइंग यू इन द क्लास. Students are very nasty, they are very ruthless. If you, so this is how it is calculated, madam. So it is not always 10 to the power